So let's start off with the concept of visual search. It should be pretty straightforward, right? It's an important part of many different applications, stuff you are probably familiar with in your day-to-day lives. But the basic problem is that you're searching for some sort of object in visual data, right? So we're going to use a running theme today with these cars, just as an example. But if I showed you a picture of the car on the left and said, hey, does it match any of the cars that we have on the right? Some folks might recognize that as I believe it's a Nissan Leaf, right? Sorry, as kind of humans, the way their brains work, we're able usually to spot it out, even though, the car here is in a different environment, maybe slightly different angle. We can say, hey, that's a Nissan Leaf, that's a Nissan Leaf. We found the object that we're looking for. Right? There's lots of examples of this visual search in our day-to-day lives. Anyone who's used a photo library app on your phone, you've probably noticed it can identify your family members and tell you where they are in pictures. Right? That's a visual search that they're running. If you more advanced self-checkout systems, like as you're scanning items, they can look at the product that you're scanning and just by vision say, hey, those are bananas, this is a box of cereal, it's a box of Cheerios, whatever it is. Right. In industrial applications, if you're looking for defects in the production line, anomalies, things like that, these are visual search problems. You're looking for certain patterns. There's a number of different approaches to visual search. Before the advent of AI, there were classical computer vision approaches, things like SIFT and SIRFT. I'm not going to go into those. They generally kind of look for features like edges and things like that to define objects. And they are scale invariant, which is what the S stands for. But those are kind of the pre-AI approaches. And then with AI, what we saw is kind of first, we saw a lot of what are called closed-set AI approaches. And those are your classification models. If you've seen anything like a cat detector, you give it a picture and it says, oh, yes, this is a cat, or this is a dog, that would be a classification model. You give it an image in, and it'll classify it among a fixed set of classes, right? But you've explicitly trained for those classes, right? And then you have things like open-set AI approaches, which is what we're really going to focus on today, which are not necessarily tied to any specific classes. So you didn't have to train for any particular class. You can kind of give it a sample and say, this is the sort of thing I'm looking for. Can you find it? Right? And that's an open set AI approach.